more forgiving than the actual spec. Yeah. You've got to exactly match the spec. Yes, any questions? There was another hand waving around somewhere.
The tester, it did not used to strip out the white space, but now it does. Like it was.
Okay. So the format of what you have to print out is nothing to do with the tester. The part of the program that tells you what you have to print out is the line that says you must exactly match the output of this web page. So you must exactly match the output of that web page. Does that make sense? Now, if you don't, then it's not as though it's an all or nothing in this assignment. It's not as though that means you'll get 0. I mean, you'd lose a few marks for every little thing. So maybe if you had extra bits of white space you weren't supposed to have, maybe you'd lose half a mark or something irrelevant like that. And maybe if you, I don't know, got everything exactly right, but you said Thurston instead of 1,000, because Thurston is a Viking name. And if you made that mistake, that would be just one mistake, but you'd fail millions of tests because of that one mistake. Nonetheless, we wouldn't take off millions of marks. Okay, we'd just take off some marks. So we're going to be very compassionate when we're marking, and we're going to be aiming to reward you for what you've done. So one silly mistake that has a catastrophic effect on your program won't have a catastrophic effect on your marks. And someone asked me yesterday, or the day before, they were just worried because their program wasn't handling a large range of numbers. And they said, what do they have to get up to pass the performance tests? Like we haven't worked out the test cases yet, so I wasn't able to answer them. But I sort of didn't need to answer them because I said, it doesn't actually matter how well your program goes. I have no line in my head where I'm thinking, anyone that does better than this is passed and anyone that does worse than this is failed. Because pass and fail means different things for different people. If you've never programmed before, then anything you can do is fantastic and is a pass. And if you're already able to program, then I expect you to be able to do everything, and that's a pass. May the Lord show me a sign if I'm wrong. So basically, don't get any mark you want. It doesn't matter. Marks really for this assignment don't matter. It's out of 10. At the end of the courses, you're going to just think it's a joke to be worrying about something that's out of 10. You'll get to the last week of term and you'll have something due that's worth 30 and something due that's worth 50. And you'll be saying, I can only spend 10 minutes on the thing that's worth 30. And then you'll be thinking, I spent 6 weeks on something that was worth 10 marks. So the marks are just irrelevant. You will pass this course if you can program. I guarantee. I'm not used to people failing the courses. The people that fail the courses tend to be people that willfully don't turn up to lectures and willfully don't hand things in or who cheat or something like that. I expect everyone in this course will pass the course. You don't have to worry about passing. What you've got to worry about is how you transform yourself. And for example, going back to that video of the guy roller skating, right? That was really cool. Remember the guy that was roller skating? You looked at it and you felt jealous. It would be very easy to get a video editing program and remove his head and stick your own head on it. And you could show everyone that video and they'd think you were so cool. But would that have achieved anything? Yes, yes, if you care about other people. Yeah. In education, we call that extrinsic motivation. If your motivation at uni is to do with other people, then yeah, you care about external things. Extrinsically motivated students care about what their parents think about what their marks are, or they've got a scholarship they've got to get, or they've got all these external factors. Intrinsically motivated students are students who do what they do for themselves because they want to do it. I'm hoping you're all intrinsically motivated. That's why you're here. Intrinsically motivated students tend to perform better at something we call deep learning, which is really understanding what's going on. Extrinsic motivation tends to correlate with what we call surface learning, which is memorizing crap for the exam and then forgetting it straight away. The HSC is all about extrinsic motivation. You weren't really interested in any of that stuff. You learn a whole lot of crap, and I bet a week later, I remember after history, even as I was walking out of the exam, those quotes were just falling away. What did that prove? It proved nothing. So if you're intrinsically motivated, your mark is irrelevant. If you put your head on that video on the guy on the skateboard, it would impress other people, but you wouldn't have learned how to skate.
But you develop your video editing.
You develop your... I like the way you think. Okay. That was Stephen. Okay, now that was Stephen, one of the class reps. Let me say there's a bit of kerfuffle on the forum last night because some people were saying the elaborately and detailed voting system I worked out wasn't completely fair. And I thought about it and they were absolutely right. Remember the voting system was you had to shout if you wanted that particular class rep? And I realised, of course, that has overrepresented loud, obnoxious people. and underrepresented shy, quiet people in the voting. And of course, the whole point of class reps is for the shy, quiet people, because the loud, obnoxious people come to me anyway with their problems. So I'm sorry, but we've done it. I don't want to do it again because we spent so long doing it. But I thought what I'd do is instead, everyone that stood for election as a class rep, I hereby nominate you a class rep. So all those 100 people that stood, and it's never happened before that so many people wanted to do it. Normally I just say, who wants to be a class rep? And after 10 minutes eventually, okay. Someone sticks up the hand of the guy that's asleep next to them. And that's it. So here we had so many people wanting to do it. It was fantastic. And it was amazing. So everyone that wanted to do it, well done. And all of you were amazing for wanting to be, that's so cool. So everyone that wanted to be a class rep, you're welcome to be class rep. Those 3 people are still the 3 that I'm just going to list as the ones to contact, just so it's not confusing to contact everyone. But every of the other guys I'll list somewhere. And I'll set up, I have a little forum section for the class reps to debate things amongst themselves and to talk about things and say, oh, someone said this, should I bring it up? And, if you just want to discuss or plot, overthrow or mutiny or something, there's a little forum there that I promise I won't look at. And maybe not, plot mutiny on your own forum probably is a better strategy. And I'll put, so everyone that stood for election, just put your name on the wiki page that wanted to do it and you can have read access to this forum and you can be a class rep. So there, okay. Now, how are you going, guys? Are we recording now? Okay, so let's just go back to the start. Oh, you can't see anything. Sorry, guys. Oh, because you're looking at my computer. That's the wrong computer. And the lights are on. Everything's wrong. Okay, let's just go off. So before I was pointing to things, you were just politely not mentioning. Yeah, that was very polite of you. Thank you. Let's go dim down the lights, dim down the lights. Make the font bigger. This is Firefox, so I can just go Control plus. Shh, 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 shh. Here we go. Oh, class reps. We've done that. That was today. Assert. All right. Now here's yesterday. By yesterday, I mean Monday, of course. Yesterday we wrote a program to add up the numbers from 1 to n. And here it is on my computer. Where's my computer? Here. It was, ooh. Or here it is if you're not such a visual person. I'm going to start up something called Xcode, which is on my Mac, which just gives me a text editor and that calls GCC automatically, so I just have to have one window open instead of flipping between the 2. Tutors have told me that some people are still using Pico in the labs. Pico is crapo. So try not to use it. You're welcome to use it. We taught it first so you'd have a baseline. You can always survive with Pico. No matter what goes wrong, you'll be able to survive. But if you want your life to be more pleasant, use in the labs gedit, or what else should they use in the... No one say Vim. What's that? No, I knew that would happen. Serious suggestions? What's it? Kedit. Kedit? Type in Kedit. Kwrite? Ask your tutor in the labs. There are hundreds of visual editors. I have no idea which ones we have there. Shh, no one call out anymore. Use some other editor because it's much more pleasant. At home, use context and SCP the files up. It's much more pleasant. There's lots of data on the wiki about how to do that if you want to do it. You can use Pico if you want. The day before the assignment's due, you probably don't want to learn a new editor, but as quickly as possible, switch. If you've got a Mac, switch to Xcode. You get it for free with the Mac. Here it is. I've clicked on Xcode. It started. Notice it started. It does nothing when it starts. All that happens is up the top, you see the word Xcode. How do you use this amazingly complicated tool? It used to annoy me a lot to even get something compiled. So shh, everyone be quiet and just watch in 3 simple steps how to use Xcode. Step 1, click on File. Step 2, click on New Project. Step 3, look at that. It's so confusing, all those options. We're just going to shut that down altogether. We want Command Line Utility. Standard Tool. That's the nickname. No, I won't. Then we'll go on. And we'll shh. No, I said today we're not making any jokes about any companies or CEOs thereof. So we're going to type in the name of the project, and let's say it's week 3. What is this? Lecture 3. That's a bit confusing. L looks a bit like. No, I'll put an underscore in there. L3. Lecture 3. Capital L. Week 3. Haha. Okay. And then what I do, I go choose, because I've previously chosen other directories to do this in. You guys don't have to do that. It'll just change it to the directory I've chosen. Pick some directory, it doesn't matter. Then you click finish. This is only working if you've got a Mac. And ta-da! It's made it for me already. And if I double click on main, ignoring all the other confusing things, you'll see my program here, which happens to be called main.c. And then into that, you type the program you want. And here's a copy. Ta-da! This is the code that we did yesterday. Let's have a look at that. Sum 1 to n, there's the, at the top is the function prototype. Oop, wrong mouse. Here's the body of the code, the main function, and notice as it calls sum to n below. Okay, now what have I done here? I've done something called assert n is greater than or equal to 0. With that recursive function, it makes sense to talk about the 0th triangular number, or summing all the numbers from 0 to 0. And it makes sense to talk about the first triangular number, or summing all the numbers from 0 to 1. And it makes sense to talk about the nth triangular number when n is a positive number, which is summing all the numbers from 0 to n. But there's no such thing as the -3rd triangular number. So my program, my recursive program, assumed that the base case was what? What's the smallest, simplest case I assumed? N is 0. Yeah. Look, if we started at -2, what's going to happen? It's going to fail this test, and it's going to call sum n-1 on n-3. And then n-4 and n-5. It's just going to go on forever. It's never going to hit 0 by subtracting numbers from a negative number. So it'll go on forever and it'll crash. Yes?
Well, why don't you make it an unsigned integer?
Oh, but hey. Shh. So, because you're distracting me. My mother is picking different people every day. Okay, yes, question. What about overflow? It might overflow, yeah. Something weird will happen. Who knows? It'll be system defined. What's going to happen is it's going to run for a long time, and at some point it's either going to subtract 1 from a number that it can't subtract 1 from because it's the smallest number it can represent, the most negative number it can represent. At that point, the system will do one of 3 things. It'll explode in some way and give an error. It'll subtract and go back to the highest number and keep going down again and consider all numbers as a loop, or it'll do something else. Who knows? Which is it allowed to do? Any of them. Okay, it's exactly like I was talking about the assignment and the assignment spec. Subtracting numbers from the smallest possible number is undefined. After that, we're in no man's land. It can do anything. So I don't want to ever get to that state of my program doing something undefined. I want to know exactly what it's going to be doing at every time. So I really need to make sure that this program only ever works for positive numbers. Now there's 2 ways of doing that. One is, I could up here, when I scanf the number, I could say n to n greater than 0, and then I could say if n is less than 0, print what? I said enter. Okay, we could do something like that. If we do something like that, we're interfering with the program logic. Okay, so the program logic is actually dealing with this problem. And maybe we'd keep looping until they entered the right thing, but in some way the program logic would be dealing with the error. That's number 1 way of dealing with error. Number 2 ways of dealing with error cases, when the user types in the wrong thing, is what? Just tell the user, warn them, but keep going regardless. Tell them not to before they do it. No, well, we have. Oh, you mean say? Like anticipate them. Okay, so 1 is adjusting the program flow or printing out messages. 2 is abort the program, which is sort of adjusting the program flow, but that's exception handling. That's a very nice way of doing it, just abort the program.
Take absolute value.
Try and repair the problem in some way. So if someone does something stupid, we try and work out what they really meant and do the right thing. Yeah. So one is abort the whole program. 1 is keep asking for the input until they give it. 1 is try and fix up their mistake. 1 is try and make do. I think that's sort of what he was saying. Take the absolute value. So work out what's happened and try and guess what they've done and fix it up. The one way you haven't mentioned is my favourite, which is number 4, which is who cares? You say that's their problem. Anything that happens after they've typed the wrong number is their fault. Now, which of those 4 strategies is the right one to use? Well, it depends on your problem. You never want to abort out of a program if it's controlling the airlock on a submarine, okay? I'd have some sort of guess what they really meant function in there. But you never want to have a guess what they meant function if there's any chance at all you might guess it wrong. Because that's the worst sort of error. It's an error that's going to happen, and then suddenly the computer's making a guess and trying to fix it up. And it's Mr. Dumbo. If you can't get it right, the chance of the computer fixing the error up is even more remote. So a program that plows on trying to fix my errors for me is the one I hate the most. I like to know when my errors happen so I can see what they are. I don't want it to second guess me. In this case, when you ask users for input, it's pretty more or less obliged on you to assume they're going to do the wrong thing and to have some extra program logic to deal with it. Yeah, to keep asking till they type the wrong thing in or something, right thing in. But in the middle of your program, suppose I've written this sum 1 to n function and I've released it to the world and other people are using it inside their programs. So I've written it and you're going to use it. Now my program, my function will explode if you stick a negative number into it. But I'm not writing the main function. Is it up to main to make sure that a negative number is put in it? Or is it up to sum 1 to n to make sure a negative number is put in it? Yeah, it's all gone red. I'm doing that to create tension. Which one should it be? Who should look after it? Well, we say that when you write a function, you should state your assumptions. I'm assuming that this function is going to get an input in this range, and it's going to have this behaviour. And if those assumptions are met, it's the duty of the function to produce the right output. And if those functions are not met, if those assumptions are not met, it's the fault of the calling program. It's exactly like I was saying for your assignment. I'm assuming, you can assume safely in your program that I will only use a non-negative number and a number less than that limit. And if I stick a bigger number than that in, it's my problem. Your program can do whatever it wants, it's my problem. So we normally say it's up to the person that writes the function to make it really clear what they're assuming, and then it's up to the person that uses the function to make it really clear, to make sure that they comply with that, right? That's called a contract in programming. But how can you document in your function the assumptions you're making? And because we don't trust anyone, what should we do when they stuff it up? Well, we do something called an assertion. And that's what I've done here. You assert some logical condition. So here I'm asserting that n is greater than 0. I put my assertions, these are called my preconditions, at the top of my function. And it is all the things that I rely on being true at this instant. And if these things aren't true, we're screwed. This is checked at runtime. And if those things aren't true, actually the program will abort with a really helpful message, which is really nice for testing. So whack assertions in whenever you've got these things called preconditions. Does that make sense? To get assertions, you need to hash include assert.h. Yep, it's a standard library, so there you go. And what's happened here, Stephen, I don't think your line was terminated there. I'll just delete it. Do you mind? Is that okay? Yes. There we are. Done, 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 done. So I hash included assert.h, and down here I've said assert n is greater than 0. Now let's run the program. To run the program in the Mac, you just click the build and go button. Build and go, woohoo! Oh, and it gives me nice little error messages in the right spot. N is undeclared, first use in this function. Oh, okay. It's called, scanf number. Ampersand. Imagine leaving that out. And let's go, build and go. Ta-da, it's happy. Now click on this little window here and it shows me the output of the program. Enter n greater than 0, and I'm going to type in 8. Oh, no, I'm not. I'm going to type in 8 on this keyboard, the one actually connected to the computer. And it's going to say sum 1 to n of 8 is 36. It's correct. And now I'm going to run it again. Go. And then I'm going to say minus 5. What's going to happen now? The assertion will catch it. We won't drop into an endless loop. The assertion will print out a message. And luckily, it's a really friendly one. It prints out. It's gone into a debugger. Ignore the debugger thing. This is all you'll see if you're using running it on the command line. Assertion failed. N is greater than 0. It tells you the function, tells you what file it's in, tells you what line it's on, and it tells you the condition that failed. It's brilliant when you're testing. So whenever you're in the middle of a program and you think, oh, now at this point, I know the number I've got is smaller than 1,000. And you do all this logic depending on it being thought smaller than 1,000. What should you stick in your code at that instant? assert n is less than 1,000, or whatever it is. It's just documenting what you know is true. So if your program relies on some condition that you cleverly have been able to work out, well then damn well state it explicitly. That helps anyone reading your code, and it's also checked constantly. So if you ever get that wrong, the runtime system will tell you. Okay, so let's go back to, that's assert. I wanted to tell you about some other types. Remember we started introducing new types yesterday. We talked about float, remember that, and long and double. There's another integer type, another arithmetic type, another numeric type called char. And char stands for a character. And when you print it out, it's just like in 8918. It's just like instruction code number 24. When you print it out, it prints that character. So let's have a look here. Let's actually do it in our program. We'll say enter n. Let's just comment out this printf here. Let's not use that. And let's comment out the scanf. And let's change this print to say something like, this is the first character in the alphabet. %C means character. And now characters you write between single quotes. What's the first letter in the alphabet? Now look, A bet starts with A. Okay, let's run it now. Oh, unused variable number. Yeah, it is unused. Okay. Now it's gone. It's compiled it, it's happy, and oh, where's my little windowy thing? Oh, my screen is a bit smaller than I'm used to. Now we're using this large font. Let me shrink this to the side, and I just have to say something like, where is it? View, it's something like console. Run console. Here we are. This is the first letter of the A bet, A. See, it's printed A, the letter A. So characters, chars, are just single letters between quotes. And that could include anything. It could include backslash, or no, could include forward slash, or it could include punctuation symbols like underscore or a space. Any symbol, any one-off symbol in the ASCII table that you've seen is a character. Now, bizarrely enough, in most modern languages, characters are regarded as a proper type of their own, but in C, a character is really just shorthand for a number. It's exactly like in 8918. So when we're talking about the letter A, what C's thinking we're talking about is the ASCII code for the letter A, which is 65 for capital A. All right, let's have a look at that. So can I just, this is A, right? We're printing it out as a character. Build and go, and it prints out, this is A. And it prints out A. But if I told it to print it as a number, because this format string is just displaying how, controlling how it displays it. Underlying, it's thinking of it as a number. So let's just say, oh, print that just as a number. It'll be equally happy with that. And it'll say, this is A. It's 65. Does that make sense? And you can even go the other way. This is A, printed out as a character, 65. Print 65 as a character. This is A. See? It's like a miracle, isn't it? So it's actually really annoying because characters are different to numbers, and regarding them as numbers is very frustrating because you can make all sorts of mistakes now that the compiler won't pick up necessarily. Like you could add a number and a character by accident, and normally that wouldn't make any sense, but the compiler won't detect you're doing something weird with types. But sometimes it actually does make sense to add a number to a character, so sometimes it's a blessing in disguise that the type isn't enforced properly here. Can you think of an example where it's worth adding a number to a character? Yeah.
If you need to uppercase all the letters.
Yeah, if you want to go uppercase to something, normally they're a constant amount, in ASCII they're a constant amount up from the lowercase letters. Or if you wanted to do ROT13, an encoding system, or if you wanted to do the Caesar cipher, where you replace A with B and B with C, you could just say, get the letter I want, input. Oh, let's do that. Let's write an encryptor. This is the encryptor. Okay, not very well spelled. This is the encryptor. Now you type in a letter and it's going to print out. This is the encryptor. Oh, printf. Oh, okay, here we go. This is the encryptor of whatever letter you've typed in. And we're typing in a letter, we'll call that the plain text. And we'll also print in the plain text plus 1. Okay, here we go, and we'll just go, char plain text. And then we'll go scanf %c, whoop, plain text. Thank you. How could I forget that? Here we go. Now it started running, it hasn't printed any message to help me, but I type in a letter now, it's going to encrypt it in a way that my little sister can never decode. I'm going to type in A. The encryptor of A is B.
Type in Z.
Type in Z. Okay, let me just make it look more sexy. Now it's a GUI. Okay, let's run it. Type in Z. I like the way you think. Z. Curly brace. So all my Zs will be curly braces and she'll never even understand a word of it. Let's go to the zip today to see the elephants. Yes?
I've got a question. If you put the number, what happens if you put a number, one of the 0 to 15 between unprintable control codes?
Oh, yeah. What's the answer to that question? Try it and see. Yeah. How does it print out numbers that can't be printed? Try and see. There are some control characters that do special things like sounding the bell on the computer and do various things. Some of the low numbers below 32 aren't supposed to be displayed. What happens when you try and display them? Oh, try and see. Try and see. Do you use someone else's computer? Okay, so that's characters and chars. Now, we still haven't seen how to put a whole lot of chars together. That's called a string, and we won't see that till next week. Oh, but we can do something neat with char. Because chars on this system, on most systems actually in C, go between, depending if they're signed or unsigned. Oh, I can never remember. I think normally, does someone know? Are chars normally unsigned? They're normally unsigned, aren't they? Does anyone know? They're normally signed, are they? Oh, well, all right, anyway. Oh, and what do I mean by signed to the 57% of people that had no idea what we were talking about then? If I've got 8 bits, I've got how many different combinations that I can make out of 8 bits? 256. So I could store all the numbers from 0 to 255. But if I wanted negative numbers, or I could store all the even numbers between 512. Yeah, I mean I can just assign these combinations to any numbers I want. Normally it makes sense to assign them to sequential numbers, but I didn't have to start with 0. I could start with negative 128, negative 127, 0, 127. Ooh, if we add that up, there's 256 of those. And but it's just assigning different numbers to them. This is called an unsigned variable where we don't worry about the negatives. So we just look at all the numbers starting with 0. And the signed ones split the range in half. So ints are signed normally. So if you've got 32 bits to store an int, essentially you've got 31 bits of positive int and 31 bits of minus int you can use. Does that make sense? Okay. Now characters, while the system normally has ints being the convenient unit of store for the system, so I said before on 8BMC our ints would be 8 bits long, and say on my 32-bit machine here the ints will be 32 bits long. Is this a 64-bit machine? Yeah. Oh, well, then I guess they'll probably be 64 bits long. Depends. Yes, because now I'm thinking about it, they're 32 bits on this machine. Maybe that's a compatibility thing. Maybe Apple are trying to make their old machines with 32 bits. You're right, it is. How about that? It is normally the case that an int is the natural size of storage for a system. Sometimes I only want to store 1 byte. I don't want to store 4 bytes to store a number. It'd be nice to have a type that was called byte. Chars store only 1 byte worth of stuff. Chars only contains 256 combinations. So if I only wanted to store small numbers, I could store them inside a char. But what do you think of that from a cunning point of view? That's cunning, because it doesn't take up much space. What's it like from a readability point of view?
Like you're reading a hacker's work.
It's like you're in hacker land, aren't you? Yeah, it's like you're adding together letters, knowing really you're adding together numbers. It's very confusing. We shouldn't call it a character if we're thinking of it as a number. We should call it a number. The right name for it would be to call it a byte. So what we really need is a type called byte. If only there was some way I could add a type to C. Oh, there is. All I have to do is say typedef char byte. That's saying from now on, everything between there and there is inserted into the program wherever you see the word, wherever you see the type byte, sorry, not inserted, it's not exactly the same as hash define. Wherever you see the type byte used, I really mean char. So now in my program, it's just a synonym for char. But it's a nice synonym because now I can say byte plain text. Oh, well, byte number, read number, 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 number. Build and go. Enter a number. I'm going to encode 56 as, oh, it printed it as 53. Who was expecting that? You were. Okay, don't tell me why. Let me have a look. Because I wasn't. What have I done? Percent. Oh, thank you very much. No. Oh, yes. So what did it read in? It read in, what did it do? We said scanf percent C. It's wanting, I know you know the answer. I know, well done, guys. It's wanting to read in a character. What did I type in? 2 characters. How many did it pay attention to? 1 of them. It thought I was typing in a 5. What's the code for 5? 53. That is so cool. Look, let's try that again. Let's just go again. I'm going to say, let me just type in 53. See, it works. Does that make sense to everyone? It read in the 5 and it thought it was a code. So I don't want it to read it in as a character. I want it to read it in as a number. So I've got to say percent D. It's a number in decimal. If I said percent X, it would read it in hexadecimal. But I don't want it to do that. Hexadecimal is base 16. It just talks about the format the thing's expressed in, not the actual thing itself. So let's run it again one more time to check it works now. Build and go. OK. 56. 56 goes to 57. Ta-da! OK. So you've seen chars and you've seen typedefs. Now, if you wanted to print a number out unsigned, let's pick a really big number. Let's just go for the biggest number we can think of. It's a byte. 257. Well, it's a byte. No, that's bigger than we can think of. 255. That's got to be the biggest number it could read in. What's it going to print out? -1? Why did it think 255 was -1? Because chars are normally signed. So the first 127 combinations it regards as being these guys. And then the next 127 after that, so if you end at 128, it starts at this end and goes back. Does that make sense? So let's just add in, let's just convince you of that. Let's go 127. We'll see what 127 plus 1 looks like. Oh, let's try that again. Let's try 128. Oh. Oh, that's very funny. Welcome to the land of C and types, because what's happening here is what we call an implicit type conversion. When it does number plus 1, what sort of arithmetic is it doing here? It's doing integer arithmetic, not char arithmetic. I'd have to make it a char. Oh, this is confusing. I could say, force it to be a byte. Force that to be a byte. Oh, in fact, hey, oh, why don't I just do it twice? That'll make it clearer. This is the input. This is the output. And I'm going to have two numbers, number and output. And what have I got? Thank you. Yep. Percent D. And I'm going to print it output. Okay. And then we're going to read in the number, and then we're going to add 1 to it. Output equals number plus 1. All right, looking what's happening here. Output and number are both bytes. It's going to read in a number in decimal, so it's expecting me to type it in using digits. It's going to print it out in decimal using digits. It's going to add 1 to that number. That will be, could possibly be an integer addition, or it could possibly be a byte addition here. I'm not sure how the automatic type conversion it's going to do. It's probably going to convert that byte. It's probably going to think 1 means an integer here, isn't it? It's going to think 1 means an integer. So it's going to think I'm doing an addition of an integer and a non-integer. And to be as safe as possible, it's going to convert this to a non-integer behind the scenes. 255 is as a character converted to an integer is still 255, so it doesn't change its value. But it's going to assume this is an integer addition. So at this point, it would be 256, but now it's going to assign it back to a byte. And here's where we're in trouble. We can't fit 256 back into the byte. It's going to try and squeeze it in, but the bit at the front's going to fall off. Okay, so let's go. 127. This is the output of 127. This is the 128. Okay, so 127 plus 1 is 128. Negative 128. Yeah. Falls off the end here, comes back on here. Whew. Look, there's a lot to say about type, what we've just seen here, which is type conversions, which I didn't want to get into today and been forced to do because of my stupid mistakes. Type conversions are when you've got a value like 7 that could exist in lots of different types. A 7 could be an int, or it could be a char, or it could be a long, or it could be a double. You see, the number 7 has an existence in lots of different types. You tell C what it is initially, or it guesses if you're typing it in at the keyboard based on clues and things like that. But C behind the scenes is quite happy to just change what type it's in willy-nilly without telling you if it thinks you're making a mistake or doing something crazy. And sometimes that can be very annoying because then it behaves like you're not expecting. You think you're adding up chars, but it's turned them into integers and it's adding them up as integers. So this is called that's called an implicit type conversion. Changing type is when you've got one value that lives in several types and you just change your mind about what type it lives in. And to do that in C, all you have to do is what I did here. I commented it out. You just say the name of the type you want in front of it. So if I said, in brackets, int, in front of output, this is called a typecast, and that converts what comes after it into that type. And it's legitimate to turn a byte into an int. It's the same, the number doesn't change, it's just we change our idea about what the type is. Okay. I didn't really want to get into that because it's a bit ugly and unnecessary at the moment. But we did it. All right, now, we're going to have a break because that just completely wore me out. In the break, in this very short break, you know, I told you in the first week that I am desperately trying to get fit. And I'm ashamed to say that 3 weeks have now passed and I haven't changed my habits at all. I'm still not fit. I'm still staying up too late and eating crap. I'm still not doing enough exercise. How can that be? Because I really want to be fit. And I know what I have to do to be fit. And I'm not fit. I'm not an idiot. What's going on here? Motivation? Lazy?
It's not fun.
It's not fun? Should listen to rocky music. That's how I type my programs. I put on boxing gloves and I go. Have you seen my famous program? So,
Punching bag mannequin Bill Gates.
no, look, I don't believe in violence, and I wouldn't. As much as I hate as much as I hate what some people stand for, and I'm not necessarily even hating what Bill Gates stands for. I don't hate any people, so I wouldn't ever want to punch a person or a mannequin of a person. What's that? I could punch a company. Yeah, I could do that. Yep.
Why don't you play to your strengths? Write a program to nag yourself.
Play to your strengths. I like the way you're thinking. Yeah. I'm a great believer in that. That's a really good idea. Look, I think get a dog. Get a dog, make it really fat, feel comparatively better off. Look, I was thinking about it, and then I was listening to the health report. And I don't know if you guys ever listened to that. It's Norman Swan, this really cool scientist, medical dude on the ABC. I think he's in charge of science at the ABC, and he has his own program as well. How about that? That's got to be biased, doesn't it? Hey, Norman, would you like a program? Yes, I'd like a program. Okay, you can have this. Okay, so he does the health report. And in the health report, he was talking to a great Toronto professor guy who was really clever, studying a lot about nutrition and food intake and obesity in America and Canada. And he was saying, it's really weird. One interesting thing that arose out of me listening to this interesting show was that a lot of people do health studies on people eating food to see when they want to stop and how the signals work with stopping eating food and satiety, satedness, being full, and all the mechanics of it and the effect of fibre and various other things and da-da-da-da. And he said the weird thing is, what I worked out, I'm paraphrasing what he said, the weird thing was that it seems that the problem doesn't really lie for most people in the feeling full so I'll stop signal. It's not the stomach sensing the wrong stuff and getting... Yeah, the problem isn't down here. Where's the problem? Yeah. The problem is apparently that people have bad mental habits and they ignore these signals. And he said, there's lots of studies done about people eating food and different sorts of meals and how full they feel afterwards. And he's very skeptical of them. He called them one meal study. He said, a one meal study means nothing. To change someone's actual behaviour, you need to change their habits. They'll do something once or twice, sure, they'll get a gym membership and go to the gym once or twice or whatever, for sure. But you don't solve or they'll eat healthily once or twice or whatever. But to solve the problem, you've actually got to change their brain and change their habits. And what he said was, the problem is habitual intake versus single meal studies. Yeah, that's what he's interested in. And he said, he's got to have a consistent and constant effect. It can't just be a one-off thing. And I thought, okay, maybe that's my problem. I've thought of a couple of things and done a couple of things, but my underlying behaviour and habits are still bad. Could that possibly be it? I need a person with a whip. I'm not going there. So, okay, so that was the end of our break. Did you all enjoy it? I'd say that was one of our better breaks. Can everyone just stand up for a minute and sit down just so the blood just sloshes a bit? Keep it inside your own body though.